Now I would like to do this last example of implicit differentiation. I want to find an equation of the tangent line to sine of x minus y equals cosine of y plus pi over 4 at the point pi over 4, pi over 4. So I have an implicitly defined y. Y and x are all mixed up. I don't have an equation that says y equals some expression in terms of x. X and y are all mixed up in this equation. So this is an implicitly defined y. But on the other hand, y really depends on x. If we decide on an x value, then the y value that corresponds to that x value really does depend on x. So if x changes, y changes too. So I need to think of y as changing when x changes. So we do have this dy dx. dy dx is the derivative of y with respect to x. It means how does y change if x changes? So we need to find an equation of the tangent line. So in order to do so, we need the slope of the tangent line. Of course, the slope of the tangent line, this is dy dx. And then we also need a point on the line. Okay? The point on the tangent line that we're going to use is the point pi over 4, pi over 4. This point is a point that's guaranteed to be shared between the tangent line and the graph of this equation itself. So what we really need to do now is work on finding dy dx. And the way that we're going to find dy dx is we're going to take the derivative of both sides of this equation with respect to x. And in finding that derivative with respect to x, we will have an equation with dy dx in it. Okay, so let's start with our equation that implicitly defines y. And so we're going to take the derivative with respect to x on both sides. So let's start with the left side. I'm going to totally take the derivative with respect to x on both sides. On this left side before I move on to the right. So on the left side, I have a composition. It's sine of x minus y. So sine of u is our outside function. So first, I'm going to have cosine of x minus y, because cosine u is the derivative of sine of u, times the derivative of x minus y with respect to x. Okay, so that is cosine of x minus y times, now the derivative of x with respect to x is 1, minus the derivative of y with respect to x. Well, that's actually what we're looking for. We want to figure out what that is. So right now I'm just going to write dy dx. And that's our derivative of the left side with respect to x. Now I'm going to set that equal to the derivative of the right side with respect to x. So if I look at the right side, my fundamental structure is multiplication. So I have a product. I have x as my first function, and cosine of y plus pi over 4 is my second function. So the derivative with respect to x, I need to use a product rule. So I get 1, because that's the derivative of x with respect to x, times cosine of y plus pi over 4, plus, now I have x, I'm going to write this as, I'm writing out of it, times the derivative with respect to x of cosine of y plus pi over 4. Okay, so now I'm going to rewrite this right side and simplify a little bit more. So I get cosine of y plus pi over 4 plus x times the derivative of cosine of y plus pi over 4 with respect to x. Now I can figure out what this is with respect to y. The derivative of cosine of y plus pi over 4 with respect to y is negative sine of y plus pi over 4 times the derivative of the inside, the derivative of y plus pi over 4 with respect to y is 1. So then I need to multiply this by the derivative of y with respect to x. That's our chain rule. Times how does y change with respect to x. I know how cosine of y plus pi over 4 changes when y changes. I get negative sine of y plus pi over 4. Now I need to multiply by how y changes when x changes. Okay? So now that's what I get, this third line, that's what I get when I take the derivative of both sides with respect to x. Now, what we're trying to do is find what dy dx is when we're at the point pi over 4. So I could go ahead and solve for dy dx, get all my dy dx terms on one side, get everything else on the other side, and then solve for dy dx. But that's unnecessary. Right now, I can go ahead and input x equals pi over 4, y equals pi over 4. So I'm going to input the point pi over 4. And in doing so, then I can get a simpler equation to solve for dy dx. So I'm going to go ahead and do that. Alright, so I went ahead and did it. Cosine of pi over 4 minus pi over 4 times the quantity 1 minus dy dx. That equals cosine of pi over 4 plus pi over 4 minus pi over 4 sine of pi over 4 plus pi over 4 times dy dx. So you can go ahead and check me on that. So this is cosine of 0 times 1 minus dy dx equals cosine of pi over 4 plus pi over 4 is pi over 2 minus pi over 4 times sine of pi over 2 times dy dx. And now I can simplify. I can evaluate all these trig functions. Cosine of 0 is 1, so I have 1 minus dy dx equals cosine of pi over 2 is 0. So then I get negative pi over 4 times sine of pi over 2. Sine of pi over 2 is 1 times dy dx. And now I can solve for dy dx. I get 1 equals dy dx minus pi over 4 dy dx. Or in other words, 1 equals 1 minus pi over 4 times dy dx. I'm going to make this left side into one fraction. I get a common denominator of 4, so I have 4 over 4 minus pi over 4, or in other words, I have 4 minus pi over 4. So now I solve for dy dx, and I get 4 over 4 minus pi equals dy dx. Okay, so at the point pi over 4, here is my dy dx. So if we remember, we're trying to find an equation for the tangent line. We needed the slope, and we needed a point on the line. So right now we have the slope, and we have our point. So let's put it all together. And we have that our equation for the tangent line at the point pi over 4 is 4 minus pi over 4, y minus pi over 4 equals our slope, which was 4 over 4 minus pi times x minus pi over 4. This is our point slope form. And that's good enough for me. You can leave your equation like this. You could also put it in y equals mx plus b form, but I'm unconcerned with how exactly you write your equation for your line.